In this session, I will introduce you to ANOVA and how do we perform ANOVA on a raw data set. So we are going to study this case wherein we have the data set called BAT18, which is the 2018 batting records of 429 Major League Baseball players. And we are only looking at the players who had 100 AB score at bats scores. So the details of the data is in the BAT18 data sheet. So we are going to use only a part of it. So which has the list of the players. Let's look at how many players are there. 1264. The teams that they come from, what position they play at, the games that they played, what is their at-bat scores, and their average performance, OBP performance. All right. So we will test the difference in the player batting performance given on base percentage. The on-base percentage roughly represents a fraction of the time a player successfully gets on base or hits a home run. We'd like to discern whether there is a real difference between the batting performance of baseball players according to their positions. So there are three positions: outfield, which is LF, CF, and RF; infield, which is 1B, 2B, 3B, and SS; and the catcher, who is right here. So we have to do some calculations here. So first thing is we create a working data set. Insert the sheet. Working. We pick this entire data set and bring it here. So what is of interest is we are interested in the positions. We don't need the specific details of the players. We are looking at the at-bat score of 100. And then we are interested in OBP. We're not interested in the other scores. So first thing is we are going to create our variables for the positions. All right. And also what we can do is, before we do any calculations, because we are looking at a at least 100 at-bat scores. So what we can do is AB, and we say that equal to 100, and we can apply some advanced filters. Data, advanced filter, filter the list in place. This is the range of the list. Criteria range is here. All right, we say okay. So let's see. So we have filtered it here. We have got 430. It means 429 records. The other way is, let's kind of eliminate the data if you're not going to use it. So we just clear the filter and we sort it in the descending order, and we remove anybody who have had score of less than 100. Right, so this is our data set of interest, and let's calculate the positions. All right, so we will use a special function called as switch, wherein we look at the position, right, and we check for the values. So there are different values. SS, we call it as infielder. Next is, let's do the all the infielders. So that's 1B will be referred to as infielder. 2B will be referred to as infielder. 3B will be referred to as infielder. And LF, CF, and RF. LF is referred to as outfielder. CF referred to as outfielder. RF referred to as outfielder. And we close it. So we are able to convert this in the infield, outfield, and catcher. So let's look at, oh, we haven't given the information on the catcher. Infield we have completed, outfield we have completed, catcher is a catcher. So we take a quick look if there are any NA values, no NA values. Great. So let's create the pivot chart to generate our table. The existing worksheet, we just place it right next to it. Say okay. We want to have positions. So there are 3 positions: catcher, IF, and OF. We want to have on-bat performance. First thing is we would like to have the count of each of these. Let's take a look at it. So that's 64, 205, and 160. OF, IF, and CF. Let's look at it in the descending order: OF, IF, and CF. Similarly, we want OBP averages. We'll keep it at 3 significant levels. And we once again calculate the standard deviation now. Let's keep it at significance level 4. Let's do it for the averages as well. Let's keep it at 4 significant values. So we generated the table. We can just copy OF, IF, and CF, OF, IF, and CF. All right. So let's look at the test of independence. Now, this data is not sampled, and we do not see any collaborative behavior in the among the players. So we will say that each player performs independently. Next is we test for the normality. So what we can do is we can create the OF, IF, and C. So we can create the histograms and the box plot for these. So the first thing is let's sort it in ascending to descending order. So we have all the catcher positions here. Copy, place it in catchers. We take the infields. Copy and paste. Let's look at the outfield. All right, so let's create the histogram for each of them. We go from bottom to the top so that the histogram is placed at the top of the sheet. So here is the histogram number 1. So again, take it from bottom to the top. This is histogram number 2. We get the histogram number 3. But the point is, it doesn't seem to have done a great job of creating the appropriate bins. So we have a far more robust way of creating it. So let's look at what is the range of these OBP values. So right click and check the minimum and the maximum. So they vary from 0.162 to 0.46. So maybe we can create 30 bins, starting 31 bins from 0.16 to 0.46, and use a more robust bins to create the histograms. 0.16, 0.17, and we would go up to 0.46. That's the highest value. All right. And then we can use the data analysis tool pack to calculate the bins and the corresponding histograms for each of them. So here is our bins. So we go to data. If you have the data analysis tool pack, great. If you don't have it, you can go to tools, Excel add-ins, and select the analysis tool pack. So we click on this, and we want to have the histogram done. So we take the data input range, and we have got labels. Let's look at where is the bin. Here is the bin. And we want to have the chart, histogram done. And where we want to place it, let's change it to a new range. And let's place it here. Or let's kind of just place it next to it. Okay, so we got the histogram. All right. And this is for what OF. We can replicate the same process for OF. for the IF and CF as well. So we again go to data analysis, histogram. We only change the input range. Rest of the things remain same. Okay, output, we may want to place it elsewhere. Let's put it at T. And here is our histogram for IF. And let's calculate the histogram for the CF as well. For the catches as well, C. And go to data analysis, histogram. Go to this, select the catches. You find the place where we are going to put this table. So let's put it here. And rest of the things remain same. We get to see the chart. What we observe is these three charts where we compare with the other three charts. So these are more appropriate, more granular representation. So the quality of these histograms is far better. We do see little long tail, just one or two values in the outliers, but largely it's following a normal distribution with a strong central tendency and the skew on the either side. And we can similarly create the box plot as well. Insert box plot. Let's select the data. The X value is in B column. Y values are name is in the C column. And the horizontal labels are here. So let me select it one more time. Insert. Let's take it to the top. And let's see what's happening. Let's look at the select data. So what is it taking? So the y-axis is value comes from here. C. Okay, I come here. Select the values from here. name comes from here, data comes from here. X values come from here. Let me organize it a little differently. First thing is I say copy and say paste special as values. So there are no formulas in this. And then we cut it and insert the cut cells. So if this is the order, then I believe it should work properly. Yeah, so it was the issue with the order. So we observe there are just a couple of extreme values, 1, 2, 3, 4 in the OF, just 2 values in the IF and none in the catches. So we can assume data is normally distributed. Next we look at is the constant variance. That's the third assumption. So if you notice these 3 values of standard deviation, right, are not having much difference. So they are ranging from 0.0379, so 0.038 to 0.02426. So they are into very narrow. So we can say that standard deviation does not very much. All right. So now let's perform the ANOVA analysis on this. For that, we go to data analysis. You will find ANOVA on the top, single factor. So input range. All right, it requires the data to be arranged in this fashion. So this is our input range. So we can select it. So that all 3 selected. These are in column, and the first row is the labels row. We would keep it in the new sheet. Let's call it as ANOVA and say okay. So this has generated the table for us with the ANOVA results. And what we observe is the F statistic, which is the measure of ANOVA test, is 5.07, and the p-value is 0.006, which is significant. And let's look at, so if it is significant, then there are 3 possibilities. So let's look at what's happening. Where is the difference coming from? take this, insert, draw a line chart. Or rather, I take this 1, 2, 3. Right, and then to change the data set to only refer to the averages. We want to switch the columns so that here is our average line. And we see that OF and IF are sufficiently nearby. C is the one which is significantly away from OF and IF. Let's change the position above. Yep. So this is what we observe. So let's do a subsequent analysis called as post hoc analysis to figure out where the difference is coming from. So we know that C is significantly different from OF and IF, but OF and IF are not much different. So let's go back to our data and let's perform our post hoc analysis. So what ANOVA test does is it only tells whether these three groups are similar or different, and the difference can come from either whether OF and IF are not same, or OF and catches are not same, or IF and catches are not same, or all three of them are different. So we don't know which of these is different. So what we do is we do a pairwise analysis, t-test to data analysis, t-test, and we will assume equal variances. Say okay. So variable 1 range. So let's look at this. Variable 2 range. So that's OF and IF. My hypothesized mean difference is 0. We have got labels. Output, we would rather keep it in the same work week. So let's put it here. And we get to see the OF and IF thing. And let's look at the critical value for a two-tail, which turns out to be .73. So we don't see any difference between outfielders and the infielders. We can perform the similar test for the other two pairs. So we will change the variable range to and we would like to have the output be placed in S. Let's complete the third one as well. Analysis. Okay, this time we will change the let's put it in AW. So we have done the pairwise t-test to check where these differences are coming from. So we see that there is the difference is significant for OF outfielders and the catchers, and the infielders and the catchers. So we can refer to ANOVA sheet for ANOVA analysis. Refer to BAT18 DW for post hoc analysis. And we see the difference has emerged from, so let's kind of say that, where the difference is, where the difference is not. So we say that this so we notice that OF and IF differences are insignificant, so they are equal. OF and catchers is different, and this is different. So this is the one which I would say which is causing the difference. Other are not equal, right? Which we can see from here. So OF and C are not equal, IF and C are not equal, but OF and IF are equal. Right? So we notice significant between means of OF and C and IF and C. Whereas difference OF and IF is not significant. The text increase the width. So there is enough evidence in the observations to indicate that the mean performance of three classes of fielders is not same. All right, that's how we perform the ANOVA analysis.